right. Welcome to Unit 6, and we are going to be covering for this week sections 6.1 and 6.2. We have 5 goals for today, which I know seems like a lot, but we're going to get through it. So this might be a 2-part video, so the part 1 and then part 2. So our 5 goals are to be able to simplify ratios, to be able to use extended ratios with triangles, to be able to use cross-product property to solve for an unknown, to be able to find a geometric mean, and to be able to identify properties of proportions. So a lot of this is going to be very review heavy when it comes to Algebra 1. So you've already learned about ratios in Algebra 1. Now we're just going to take those ratios and proportions and apply them to geometry. So what exactly is a ratio? So example 1, simplifying ratio. So we need to define what a ratio is. So a ratio is known as a comparison of 2 numbers or quantities. I feel like I'm going to do the wrong comparison. If I do, I'm so sorry. Because isn't it P-A-I-R and P-A-R-E? No, let me get my phone and check. Well, I'm a math teacher, y'all. And not an English teacher. Comparison. There we go. Or it can also be known as like a quotient of 2 numbers. Oh, Lord. Oh, too early in the morning. Yeah. Or a quotient of 2 or more, because in geometry we can have more than 2. 2 or more. No, not for a ratio. Yes, it is 2 or more numbers / quantities. Yeah. Okay. So whenever we think about ratios, most of the time they look like fractions. Now, there are 3 ways in which ratios can be written. The first way that we know of is a fraction, like A over B. If I was comparing or creating a quotient of those 2 numbers. Another way is that sentence structure. It means A to B, and then of course there's also the legit just sentence, A to B. So there's different ways in which ratios can be written. Now the rule when it comes to simplifying ratios, there are 2 rules. Rule number 1, they must be the same unit. What I mean by that is if one's $1, the other one needs to be $1. If one's feet, the other one needs to be a feet. We can't do a comparison of ounces and pounds, okay? They have to be the same unit. And then step 2 to simplifying ratios, okay, is to write your answer. In the same format as given. Whew, this morning, my spelling is just very questionable. I think I need to go back to bed. Just needed to see if there was an E on format. All right. So, for example, if your question is in fraction form, your answer needs to be in fraction form. If it's in this sentence structure, it needs to be in that sentence structure. If it's in a complete sentence, it needs to be in a complete sentence, okay? So let's practice simplifying ratios. So starting with example 1, our first one says $20 to $5. So, step 1, are they in the same unit? Yes, they're both in dollars, so we're good to go. Now, whenever you're like, okay, well then do we need to do anything? Well, you do. Simplifying ratios is like simplifying a fraction. You need to get it to where the numbers can't be divided by the same number any longer, okay? So whenever I think about 20 and 5, I know both of them are divisible by 5. So I would divide both of them by 5, and then I get my final answer. So my final answer would be 4 to 1, and that is your simplified ratio. And you're like, well, do you have to put your units back in there? After you simplify, you don't have to put your units back in if you don't want to, mainly because we've already simplified it and the units are given. So now let's look at our next one though. We have 6 liters to 10 milliliters. They are not in the same unit. So what I suggest you do is take your phone or computer, or if you have an old agenda, they used to have conversion charts in your agenda. Just type in liter to milliliter, and let's see. It tells us in 1 liter is equal to 1,000 milliliters. So what that means is we're going to take these 6 liters and we're going to turn them into milliliters. So you think, okay, for every 1 liter, we have 1,000 milliliters. So if we have 6 liters, how many milliliters do we have? Well, we're just going to say 6 times 1,000 would be 6,000 milliliters to 10 milliliters. Now we're the same unit and we can simplify. So I know both of these are divisible by 10. So my final answer would be, let's see, 600 to 1, I do believe. Yep. Remember, your answer has to be in the same format it is given. All right. Now, on questions like this in your homework, you are going to have to type it in. Please do not put any spaces in, okay? Like, don't put any spaces. 4:1. If it's division, 4 divided by 1. If it's a sentence, use spacing, 4 space 2 space 1, okay? But otherwise, do not use any spacing on these two, because I'm not going to put spacing in on the answer key. These right here will not be multiple choice, okay? All right, next, example 2, still dealing with ratios. Now let's apply them to geometry, okay? So, we're going to talk about writing ratios when it comes to geometric shapes. So this example here wants us to find the ratio of width to length. We want to know, what is it, width to length. All right, and just for sake of us all having the same answers, width means up and down, length means left and right, okay? Just for the sake of us having the same answers. All right, so if we look at our figure here, our width is the up and down. That would be 5 inches. So we have 5 inches to, and our length, that would be the left and right, 15 inches. All right, are we the same unit? Yes, they're both inches. Can we simplify? Are both of these numbers divisible by something? Yes, they are. They're both divisible by 5. So if we divide both of these by 5, we can find our final answer. Remember, it has to be in the same format as given. So it would be 1 space 2 space 3. So your ratio here would be 1 to 3. All right. On these right here, again, they will not be multiple choice. You will have to type them in. Okay? All right, let's keep going. Goal number 2, extended ratios. All right, so what is an extended ratio? This is any time you're dealing with more than 2 numbers or quantities, okay? So most of our extended ratios we're going to talk about today are going to be about triangles. So an extended ratio can be written in only 2 of the forms. It can't be written in fraction form, but it can be written in the 2 sentence formats. An extended ratio that we'll be dealing with is like saying A to B to C. And it gives us an idea of how all 3 are comparing to each other. All right, so using extended ratios. We're given the extended ratio 3 to 5 to 10. Okay, and this is for the angle measures, of a triangle. And we want to know what are the angle measures. So let's talk about this. We're talking about the inside of a triangle. So we have an inside of a triangle here. What do we know about our angle measures inside a triangle? Well, hopefully you remember that the inside always equals 180 degrees. But here's what we know about this triangle. We don't know the actual angle measures. We don't know them. Boom, boom, boom. They're unknowns. But we do know they all compare by 3 to 5 to 10. Okay? They all compare 3 to 5 to 10. And you're like, okay, so the angle measures are 3x, 5x, and 10x. Yes. So now we can solve for that unknown similar number that goes in to give us our angle measures. We can say 5x plus 3x plus 10x equals 180. So if you're someone that's like, okay, so how do I solve these? Well, whatever your extended ratio is, put an x behind each of them, add them together to equal 180. That's how you solve these problems. So we're going to put all of these together, which gives us 18x equals 180. Divide by 18, and we get x equals 10. Now, are we done? No, we're not, because it ultimately wants to know what are our 3 angle measures. So all we're going to do is take 10 and plug it back in. So this one right here would be 3 times 10, which gives us 30 degrees. This would be 5 times 10, which gives us 50 degrees. And this would be 10 times 10, which gives us 100 degrees. Okay, this one will be multiple choice. It'll have on there what x equals and then the 3 angles, and you have to pick the one that is the correct answer. And there are only 3 of those on your homework, okay? All right, let's continue. How are we doing on time? Actually, we're going to stop right here. So we'll pick back up in part 2 at goal 3. Man, this one might be a part 3 video. Ooh, long lesson. Sorry.